See again, this is the question based on RLC second order, right? So we have to follow certain steps. Step number 1, we have to calculate the condition at t equal to 0 minus. Remember, at t equal to 0 minus we need to calculate I of 0 minus and V of 0 minus, right? So now you need to tell me that at t equal to 0 minus, the switch will be opened or closed. For t equal to 0 minus, it would be closed. So I am closing the switch. Okay. And again, at t equal to 0 minus, this is the condition for the steady state, right? For the steady state, capacitor is going to be open circuit or short circuit? Capacitor is going to be open circuit, and inductor will going to be open or short? Short circuit, right? So in the inductor, current flowing here, it would be I of 0 minus, and across the capacitor we'll calculate voltage, that is V of 0 minus, right? So for I of 0 minus, how many meshes are there? Only one mesh. So for one mesh we can simply apply V by R. V is how much? 10 volt, and the resistance is how much? That is 4 ohm plus 6 ohm. Both are in series or in parallel? 4 ohm and 6 series? No. 10 by 10, so answer would be 1 ampere. I0 minus, we got it as 1 ampere, right? Next we need to calculate V of 0 minus, that is the voltage across A and B, right? So voltage across A and B is how much? We can note it down like ACD. VAB would be equal to VAC plus VCD plus VDB, right? VDB is 0. VAC we can write down IAC multiplied by RAC. VCD is 10 volt, right? RAC is 4. I we already know, that is 1. Okay, but we have to see the direction, like your current is moving like this now. Okay, so that is, they have mentioned positive, negative. So according to them, their current is moving like opposite direction. As you can see that this is positive and this is negative, means their current is moving like this, right? So it would be positive, negative. Now either we need to take first sign or second sign, right? So that can be minus 4 plus 10, that would be 6 volt. Got it? So V of 0 minus, we got it as 6 volt. See, we have to consider sign also, we can't neglect it. Got it? Step number 1 done. Next is step number 2. We need to calculate what? Tell me. At t equal to 0, that is the transient condition, right? For this we need to calculate di by dt, or we need to calculate dv by dt, right? Now again we need to draw the circuit. For t equal to 0, that it's going to be open circuit. Okay, so if it is open, then there is no role of this 3 ohm, right? And this capacitor also. So rub that. No, sorry, if there is open circuit, sorry, by mistake I did it wrong. If there is an open circuit, see, if there is open circuit means there is no role of this source, right? There is no role of this source. So the circuit will become like this, and as you can see that in this we have no source, so this will become a natural response, right? So you know we need to calculate di by dt. In which formula do we have di by dt? That is the voltage across inductor, L di by dt. And in which formula we have dv by dt? That is ic is equal to c dv by dt, right? Got it? So ic is the current across the capacitor. L we know, L is how much? That is 0.5. di by dt we need to calculate, and voltage across inductor we don't know, right? And tell me, how can we calculate voltage? By applying KVL, like VC plus VR plus VL plus VR must be equal to 0. As you can see, there is no supply, right? VC we already calculated in the first part, that is we got it as 6 volt. So 6. VR is how much? I into R. I also we got it as 1 ampere, right? VL we know, that is L di by dt. VR again I into R, this time R is 6 ohm. I we already know, that is 1. L we already know, that is 0.5. So only term left is di by dt, right? So after solving it, di by dt will come it across minus 6 ampere per second. Always you will get di by dt only by applying KVL only. Because is there any circuit or there is any source? No, there is no source present. Okay. Again we need to calculate dv by dt, that is ic is equal to c dvc by dt. I we do we know I? C we know. C value is how much? That is 0.02, right? dv by dt we need to calculate, and we need to calculate. C I is equal to 1 ampere. So from this we'll get the dvc by dt value also, right? Got it? I we already calculated now. Then in the next step, as you can see that this is the natural response. Natural response means there is no source over here, right? For the natural response you can mark it also. The current across infinity is also 0, and the voltage across infinity is also 0. That is fixed for the natural, because if there is no source, current would obviously there will be no current and there will be no voltage. Got it? That is step number 3. Next is step number 4. We have to calculate the transient condition. First we have to see that it is the series circuit, series RLC, like C at t equal to 0 we have to see for the transient. RLC are in series. So 6 and 3 we can combine it, right? So that would become 9 ohm, right? And inductor value they have already mentioned, that is 0.5 Henry, and this is 0.02 farad. Okay, so it will be in series. Got it? For this, as I told you, the certain steps for series RLC circuit, again the step number 1, we have to calculate the value of alpha and omega naught. Alpha is R by 2L for series. Omega naught is 1 by root of LC. Okay. R we know 9. L we know 0.5. If we'll solve it, then we'll get 9 NP Nepper per second. Okay. For omega naught, we'll put down the values and then we'll get 10 radian per second. Now tell me which case it is. Alpha is less than omega naught, and if alpha is less than omega naught, then that would be the case of underdamped. Got it? Okay. Now I told you for underdamped case, I told you na certain steps, all the steps for underdamped. So step number 1 done. What was the step number 2 for underdamped? We have to calculate omega d. Omega d is how much? Omega naught square minus alpha square. Omega value we know, alpha value we know. After solving it, we'll get 4.36 radian per second. Okay. Now move towards step number 3. We have to know, write down the equation. What was the equation? Can you tell me? E raised to power minus alpha t b1 cos omega tt plus b2 sin omega dt, right? Then after that we have to see alpha we know, no. Omega d we know, omega d we know. But we have to calculate the value of b1 and b2, right? For this also I told you the certain steps. Remember? Yes, at t equal to 0 we have to put down the equation at t equal to 0. Sorry, wait. Yeah, for what we got the equation, that is I of t is equal to e raised to power minus alpha t b1, I of t is equal to e raised to power minus alpha t b1 cos of omega d value we know, that is 4.360 plus b2 sine of 4.360. Okay. Now our focus is to calculate b1 and b2. So for we'll put, as I told you, at t equal to 0. So t equal to 0, I of 0, then e raised to power 0, then b1 cos of 0 plus b2 sine of 0. Sine 0 is 0, cos 0 is 1, I 0 we already know. What was? That was 1 we already calculated. So b1 value we got it as simple 1. Easy, right? Now we have to differentiate this equation for the calculation of b2. I2 is equal to e raised to power minus alpha t b1 cos of 4.360 plus b2 sine of 4.360, right? Now we need to differentiate, that is di by dt, correct? As you can see that we have to apply u multiplied by v formula, u dv, right? First we need to differentiate this, then this term will remain as it is. Again we need to differentiate this, then this term will remain as it is. Okay. So I'm not complete solving, but I'm telling you, like after complete solving it, we'll get the equation for the b2, because in this case we solved b1. Now we'll get the value of b2. Okay. B2 will get it as 0.608. We just need to differentiate simple. Okay, and now we got it the value of B1 and B2. We can put it in the equation. B1 we got it as simple 1 and B2 we got it as 0.608. Okay, so we can put it in e raised to power minus alpha t means alpha is 9, B1 is 1 cos of 4.36t plus B2 is 0.608 sine of 4.36t plus 0. 0 is the natural response. Got it?